Welcome to Integer Exponents. Our objectives for today are to evaluate expressions containing 0 and integer exponents, and simplify expressions containing 0 and the integer exponents. So when we refer to integer exponents, we're referring to exponents that have whole numbers. So for example, if we were dealing with 2 raised to the 2, that'd be an example of an integer exponent. And we know that that is 4. If we were dealing with 2 to the 3, we know that this means it's 2 times itself 3 times. So it's 2 times 2 times 2, which is 8. We can continue on that pattern. 2 raised to the 4th is 2 times 2 times 2 times 2. 4 times 4 we know as 16. Okay, so this is all well for integers like 2, 3, 4, 5 that are positive whole numbers. But what happens when we get to 0 and negative exponents? Well, let's make a table and see what happens. So, if we raised 2 to the 4th, we got 16. If we raised 2 to the 3rd, we got 8. If we raised 2 to the 2, we got 4. And we know if we raise 2 to the 1, that's just 2. Okay, so what's happening to each value here? Well, we can see that it's getting divided by 2. 16 divided by 2 is 8. 8 divided by 4 is 2. And 4 divided by 2 is 2. So, based off that logic, 2 raised to the 0 should just be 2 divided by 2, which is just 1. And if you continue with that pattern, then if we have 2 raised to the negative 1, well, that should just be 1 divided by 2. So if you do 1 divided by 2, you get 1 over 2, or 1/2. Let's keep going. If we have 2 raised to the negative 2, that should just be 1/2 divided by 2, which is 1/4. And so on and so forth. So we have just discovered our 0 and negative exponent rules. So we have the 0 rule, which says any non-zero number raised to the 0 power, as we saw right here, the answer is just going to be 1. Now, if we have a negative exponent, that tells us that any non-zero number that's raised to a negative exponent is going to be the number 1 over whatever that number was raised to the opposite exponent. So, for example, if we had 2 raised to the negative 2, that becomes 1 over 2 raised to a positive 2. If we had 3 raised to a negative 3, that becomes 1 over 3 raised to a positive 3, which is 1 over 27. So if we're raising to a 0, that number automatically becomes 1. And if we're raising to a negative exponent, that becomes 1 over that same number raised to the opposite exponent. Alright, let's simplify some exponent expressions. So let's say we have 4 raised to the negative 2. So we're raising this to a negative exponent, so it's going to be 1 over that same number raised to the opposite exponent. So here it's negative 2, so we raise it to a positive 2. And we know 1 over 4 squared will just become 16. Okay, for our next example, let's try negative 3 raised to a negative 4. Alright, so same thing. We go 1 over that same number raised to the opposite exponent, which is 4. So we can do this out by hand. We know that if we're raising something to the 4th, we're multiplying that number by itself 3 times. So negative 3 times negative 3 becomes 9 twice. So our answer is 1 over 81. And if we have any number raised to 0, we know it's just 1. That one should be pretty simple. Alright, let's evaluate some expressions given some integer exponents. Let's say we have the expression x raised to negative 1, and we're evaluating this when x equals 2. So all we do is we exchange the x for a 2 and raise it to negative 1. So we have 1 over 2. Alright, for expression b, we have a raised to the 0 and b raised to the negative 3. We're told that a equals 8 and b equals negative 2. Technically, it doesn't matter what a equals as long as it's not 0, because anything raised to 0 is just going to be 1. So if we have 8 raised to 0 and b is negative 2, so the 8 raised to 0, that's going to become 1. And then we have negative 2 raised to the negative 3. So that's going to become 1 over negative 2 raised to the positive 3. So the 1's in the numerator can combine to just be one numerator. And then we can do negative 2 times negative 2 times negative 2, which is going to result in being 1 over negative 8. So just be careful here when you have that negative number in parentheses. Make sure you count and make sure that if it's an odd number, that it ends up being negative, and if it's an even number for the exponent, it ends up being positive. Let's work on simplifying a few more expressions. So for our first expression, we have 3y raised to the negative 2. We know that anything raised to a negative exponent, we end up doing 1 over, we said number before, but whatever that base is, we bring that down to the denominator, and then we change the sign of that exponent to be a positive 2. So now we can just combine this to be one fraction and write it as 3 over y squared. Alright, for problem B, we have negative 4 over k to the negative 4. So now we have a negative exponent in the denominator. Let's split these up and see what happens. So we can write this as negative 4 over 1 times 1 over k to the negative 4. So the negative 4 over 1 will remain as it is. What happens on the right hand side here is we have 1 over 1 divided by k raised to the 4th. So that's the same as, bring this down right here, 1 divided by 1 over k to the 4th. So we know that division is the inverse operation of multiplication. So to solve this, we would just do 1 times k to the 4th. Final answer being k to the 4th. So a lot of steps here. In the future, you don't have to do this. If you see a negative exponent in the denominator, just know that it goes right up to the numerator. So this is the explanation of why. But if you get a test or a quiz, you can just go simply from here to say this is going to equal negative 4 times k to the 4th. So once again, you don't have to do this part that I did here. That was just an explanation for why that happens. Alright, last problem. We have x to the negative 3 divided by a raised to the 0 times y to the 5th. So we'll work with this x to the negative 3. That's going to go and be written as 1 over x to the 3rd. We know that a to the 0 is just going to be 1, and y to the 5th remains untouched, leaving our final expression as 1 over x to the 3rd, y to the 5th. So as a recap, we've learned that anything raised to the 0 exponent power, if it's a non-zero number, becomes 1. And we've also learned that anything raised to a negative exponent becomes 1 over that same number raised to the opposite exponent. If the exponent is in the denominator, it simply goes into the numerator. Alright, I hope this was helpful, and enjoy and take care.